So, if you've been anywhere near the AI space, you have definitely seen the headlines. Gemini 3.1 is absolutely crushing benchmarks. Google's flexing, and they're flexing hard. But then I started digging into the developer forums, the issue trackers, and I found a completely different story. A story of pure frustration, one that's a world away from the official hype. Let's get into it.
And that right there, that's the core mystery we're going to unpack today. How can a model be called the smartest thing ever, and at the exact same time be called unusable? This huge gap between the hype and the reality, well, it's causing some major problems.
So on one hand, you've got the hype. You see these record-breaking scores on some of the hardest tests out there. And on the other hand, you have the reality for developers, frustration, broken apps, and a model that just feels totally unreliable. So which story is the real one? Well, the crazy thing is, they both are.
And let's be fair, before we get into all the issues, we have to give credit where it's due, because on paper, the performance gains we're seeing here are pretty significant. Google's numbers are genuinely very strong.
Okay, first up, on AGI2. This is a super tough benchmark made to test advanced reasoning, and it hits a verified score of 77.1%. In the AI world, trust me, that is a huge deal.
Then you look at GPQA Diamond. This thing tests for graduate-level expert knowledge, and it scores an incredible 94.3%. The impressive numbers just keep on coming.
And for all you coders, on SWEBench, it lands an 80.6% on a single attempt. Look, these are massive jumps over the last version of Gemini, especially for reasoning and tasks where it has to act like an agent. So yeah, the hype is definitely built on some real data.
But, and this is the big but, do these isolated, clean, academic-style tests actually reflect what it's like to build with this thing in the real, messy world? The answer, as you might guess, is a loud and clear no.
This slide gets right to the heart of the problem. You know, benchmarks are clean. They're like testing a brain in a jar. They don't test the stuff around it, the API, the quota limits, or what happens on the 47th message in a long coding session. And that gap between the clean benchmark and the messy reality is where all this frustration is coming from.
And this analogy just perfectly captures the whole situation. Gemini 3.1 is that 500 horsepower engine. It has incredible raw power. But developers are finding that the transmission, the API, the latency, the whole experience of using it just keeps slipping, making all that power almost impossible to actually use.
You know, the problems really started with the rollout itself. Things move fast, but then on March 9th, Google shut down the old Gemini 3 Pro preview and just silently redirected the model ID to the new 3.1. So imagine you're running code in production. Your model just changed underneath you with zero warning. That's the kind of move that just kills developer trust right out of the gate.
So let's pop the hood and break down exactly where that powerful engine is failing. We've pinpointed 3 specific, very real friction points that are causing developers the most headaches.
First, there's something developers have started calling the thinking tax. Second, the whole system is just incredibly brittle. And third, for a model this smart, it's surprisingly bad at planning. Let's break each of those down.
The biggest complaint, the one you hear from absolutely everyone, is the time to first token, or TTFT. Google's own docs say you actually can't disable the model's mandatory thinking step. This means you're waiting, on average, around 30 seconds before you even see the first word of a response. 30 seconds, just staring at a blinking cursor.
And those 30 seconds add up really, really fast. For a developer who's doing maybe 40 or 50 back-and-forth coding prompts a day, that adds up to nearly half an hour of dead time. Just waiting. For people whose entire job is to iterate quickly, that kind of latency just completely overshadows any benchmark score. It's a deal breaker.
The second big friction point is just how fragile and brittle the integration is. And here's the thing. Developers aren't saying the model is dumb, they're saying the product is broken. They're getting weird not found errors, 400 errors when using tools, and even silent failures where the model just gives back nothing at all. This points to stricter unannounced rules in the API. So the key takeaway is, this isn't a problem with the model's intelligence, it's a product engineering problem.
And this leads us to the third point, which is really interesting. The model is an absolute genius at complex, abstract logic puzzles. That's why it does so well on those benchmarks. But ask it to do a practical, real-world task, like write a solid project plan, it just kind of falls flat. The plans come out too short, they miss obvious edge cases, and they skip over all the nuance. And for the huge number of us who need that kind of planning skill for our jobs, this is a massive weakness.
And finally, there's the whole user experience around the safety features. It's like a roll of the dice. Developers report that a prompt will get blocked, but then they'll resubmit the exact same prompt and it'll go through just fine. This randomness just makes the system feel unreliable, and that's what destroys trust. You don't experience safety as a metric, you experience it as consistency.
Okay, so after all that, what's the path forward? We've put together a 5-point fix list. 5 concrete things Google could ship, maybe even tomorrow, to start bridging this huge gap between the model's potential and the developer's reality.
1. Fix the wait time. Make time to first token a top priority metric and offer a fast mode as an escape hatch. 2. Ship a test suite so developers can actually check if their tool calls will work. 3. Add a report mode specifically for generating those detailed plans. 4. Fix the rollout process. No more silent changes, ever. And 5. Just build a simple dashboard so developers can see their quota and what they're actually being charged for.
So, this is where we land. Benchmarks are important. They show you a model's absolute ceiling, its maximum potential power. But the user experience, the latency, the reliability, that shows you its floor. That's the day-to-day practical reality of using it. And right now, the gap between Gemini 3.1's ceiling and its floor is just way too big.
So that leaves us with our final question. Is Gemini 3.1 a fundamentally flawed model? The benchmarks shout a definite no. But is it a brilliant, incredibly powerful engine that's currently attached to a broken, slipping transmission? For thousands of developers right now, the answer seems to be a very frustrating yes.